Hey math kids, today we're going to talk about capacity, and we are in chapter 6, section D, and we're going to start with example 8. It says the volume of liquid which will fit in a container with capacity 9.6 liters. Okay, so all we need to do is know that there are 1,000 cubic centimeters in a liter. And we say 9.6 times 1,000, and that converts it. So we end up with 9,600 centimeters cubed. Okay, now we have 3,240 liters, and this time they want us to go into meters cubed. Doesn't really tell us why. So we could do it the previous way and change it into centimeters cubed. Possibly because it's such a large number is the only thing I can think of. But if we want to go to meters cubed, we're actually going to have to divide by 1,000. And I think I'm going to be a little more explicit with this. So in 1 meter cubed, there are 1,000 liters. So we're really just multiplying this like this. Our liters cancel. So our new unit is meters cubed. And so we do 3,240 times 1. And we do 1 times 1,000. And then we divide those, and we end up with 3.24 meters cubed. Okay, move on to example 9. It says find the capacity of a 2.6 meter by 3.1 meter by 1.45 meter tank. Okay, they draw a picture in their book, but volume for rectangular prism, which essentially is all we're doing on this one, is just length times width times height. If you feel like you need the picture, I'm just going to let you look in the book. And so we just plug these in. Put that in a calculator, and we end up with 11.687 meters cubed. Okay, moving on to example 10. So we have 17.3 millimeters of rainfall on a flat rectangular shed roof, which has length equal, okay, so this is the rain. Length is 10 meters, width is 6.5 meters. All of the water goes into a cylindrical tank with base diameter. So diameter of the tank is 4 meters. By how many millimeters does the water level in the tank rise? Okay, so this one's kind of hard to understand what they're talking about. So I'll definitely draw the picture on this one. So if we're the rain is given in millimeters, so we need to first convert that to meters, because when we're dealing with the roof, so this is all roof stuff, we want to be in the same units. So we're going to say 17.3 millimeters. In 1 meter, there is 1,000 millimeters. And so our millimeters cancel. And so we know that we need to do division. And so we're going to have 0.0173 meters, which is the same thing as this. Okay. And now when we're talking about the volume that's on the roof, we just have to do length times width times height, which is essentially the rain, the height of the rain. So we're going to go length, width, height, or 10, 6.5, 0.0173. Multiply all those together, and we know on the roof it's 1.1245 meters cubed. Okay, so that's a piece that we need, and that's the roof, so I'm gonna just write roof. Okay, now we're gonna move on to the tank. We'll come back to this number too, by the way, but just hold on. So we have this tank, it's cylindrical. And it's filling up with water. And they tell us that the radius is 2 meters because they say the diameter up here. The diameter was 4, so the radius is 2. And we want to know how much the height changes. Is that what they asked for? By how many millimeters does the water level in the tank rise? Yeah. So essentially there was some height to start with, and we want to know the change because of the rain. So we're essentially looking at this water and just want to know the height from here to here. Okay, so the volume added to the tank is just going to be the area of the base. So area of the base times the height. Okay. And we know the area of the base is pi r squared. And then our height in there. So we can say pi 2 squared. And we don't know the height at the moment. But we know how much water fell on the roof, and so we can use that as our total area. So we have 1.1245 from this number that we found on the roof. And then we just need to solve. So let's simplify a little bit though. So that's just going to be 4 pi h divided by 4 pi, divided by 4 pi. And h equals 0.0895 meters. And so that's the amount that this would change. All right, that's kind of a weird problem. If you need additional help, come to Math Lab, but for now, calculator.